All right, everyone, welcome to Lesson 3, where we're going to start looking at more advanced concepts associated with switching. Now, specifically, the topics that I want to cover here are going to include some of the things that we kind of take for granted when we look at the way things work in our Layer 2 infrastructure. And one of the first ones that I want to talk about is what I alluded to in in the previous video, and that is the fact that we have the idea of what we call our physical topology and what we call our logical topology. Now, what I'm alluding to here is the fact that if I have a physical topology, let's take into account that I have a series of switches that are connected to one another, and as I said, these devices are going to be connected to hosts. So let's just say host 1 and host 2. Now basically this is what we've discussed in the previous videos, except I'm expanding the topology to include more than one switch. Let's go ahead and say SW1 and SW2. Now, in order to have a unified topology, whereby these devices can pretend as if they're part of the same Layer 2 infrastructure. And in data center, you'll hear us use the term fabric a lot. So this is one of the first introductions to the concept of a fabric. What we're looking at here is a Layer 2 fabric represented by two switches. But as long as these switches are not connected to one another, what's going to end up happening is they're going to act as two separate domains, which means this host cannot talk to this host until such time that I choose to extend connectivity between the devices in question. And what I want to do is I want to make certain that I have the capability of being able to support a lot of the capabilities, technically all of the capabilities, that Cisco integrated into their switches. One of those concepts is the idea of a VLAN, a virtual local area network. So that's where we're going to begin when we start looking at this, and then what we'll do is we'll take our segue into this idea of physical versus logical topologies. So a VLAN, in all honesty, is a logical topology, and here's why. Because, let me change pin colors here. So what I get when I look at a concept like a VLAN is I have the capability of acquiring a switch. Now let's just say this is SWX. Not necessarily part of the scenario here, but I am trying to use this for the purposes of illustrating a point. Now we said that I have the capability of having ports on my switch. And we said that those ports are going to be typically connected to hosts. Let's just say host 1, host 2, host 3, and host 4. Pretty much exactly what we have over here and what we've talked about to date. Now, the element that we need to pay attention to here is that I can actually break this switch up into a series of logical network segments. Now, these logical network segments are VLANs, virtual local area networks. So the object is that if I wanted to, I could actually come in here and I could bifurcate this switch in such a fashion that host 1 and host 3 are going to be in their own broadcast domain, and host 2 and host 4 would be in their own broadcast domain. So basically what's happening here is I'm actually coming in here and I am subdividing this switch logically such that it really thinks that it's actually two separate devices. So from the perspective of the implementation here, this is a logical division whereby I have one physical switch that is acting as if it is two logical separate components. But what we want to do is we want to cycle back to this idea because, again, there are some fundamental things that I want to make certain that we understand. The first, and probably the most significant, is going to be what represents a collision domain and what represents a broadcast domain. Now, we said that we use VLANs to isolate broadcast domains. Now, what that translates to in this specific scenario is that this device and this device can talk to one another, and this device and this device can talk to one another, but I cannot talk inside of this switch between these networks because remember I said that layer 2 communication was a host to host communication. Layer 3 communication is a network to network communication. So in this scenario, I loathe the analogy or the terminology, but for the longest time, we have always equated a VLAN with a network, and we've treated it as if it was a one-to-one scenario. Now, the reason that I hate this as far as an explanation is that you're going to learn when we get into software-defined networking and we start looking at the ACI, you're going to find out that this necessarily is not true because of the fact that inside of the ACI we have a change in terminology. But I'm not going to go there right now. What I want to do right now is I'm going to preserve this, and then what I'm going to do is I'm going to move into a conversation about how switches behave at layer 2. Because what you're going to find is a switch actually has a collision domain for every port on it, and it actually gives me the capability through the creation of VLANs to be able to create multiple separate broadcast domains. So with that being said, what we're going to do is we're going to stop this particular portion of the recording now, and then what we'll do is we'll return and I want to talk about these fundamental concepts that directly impact the functionality of switching when we start looking at it beyond just the basic configuration. I'm Terry Vinson, and I'd like to thank you for learning Data Center with me.